Hi, welcome to Hashtag Math. We're going to talk about derivatives of inverse trigonometric functions. It will all make sense. In this first example, we're going to find the derivative of the inverse cosine. At all times, we assume we are on the domain of the inverse trig function. At the end of the video, I will include a table containing the inverse trig functions and their domains and ranges, so you can refresh them. Okay, to start the problem, we start with the definition of the inverse cosine. So, cosine inverse of x equals y if and only if cosine y equals x. And then we derive cosine y equals x on both sides. And we get d dx of cosine y equals d dx of x. d dx of cosine y, this is the chain rule. We are deriving implicitly. So we derive the outer function, which is negative sine, keep the y, and then multiply by the derivative of the inner function. And that equals 1, the derivative of x. Now we just divide by negative sine y on both sides, and dy dx equals negative 1 over sine y. Now we want to write the sine in terms of the cosine to be able to plug in the x. And for that, well, the Pythagorean identity. Sine squared y plus cosine squared y equals 1. So sine y equals square root of 1 minus cosine squared y. And we substitute that here. So dy dx equals negative 1 over the square root of 1 minus cosine squared y. And cosine y is x, so we get dy dx equals negative 1 over square root of 1 minus x squared. So when we derive cosine inverse of x, we get negative 1 over square root of 1 minus x squared. To derive the inverse of the secant, we follow the same procedure. Y equals secant inverse of x if and only if secant y equals x. And then we derive secant y equals x on both sides. So d dx of secant y equals d dx of x, just like we did before. Now, secant y is chain rule. The derivative of the secant is secant tangent, so secant y tangent y, and then attach dy dx for the inner derivative, and the derivative of x is 1, and just divide by secant y tangent y, and so dy dx is going to be 1 over secant y tangent y. Now to return to x, secant y is just x, so this is simple. We have to turn tangent y to x. Tangent squared y plus 1 equals secant squared y, so tangent y equals positive or negative square root of secant squared y minus 1. And secant y is x, so tangent y is positive or negative square root of x squared minus 1. Then dy dx is going to be positive or negative 1 over, because secant y equals x, then this is going to be x square root of x squared minus 1, because this is tangent y. So we get dy dx equals positive or negative 1 over x root x squared minus 1. But what can we do about the positive and negative signs? If we follow the tangent line of the secant, you see it's always positive. Here it's always positive, and on the other side of the secant is always positive also. So the outcome has to be positive. How would we make this positive? Well, we look at the domain. If x is bigger than 1, then x is positive, and dy dx is just 1 over x times the square root of x squared minus 1, because the square root is always positive and x is positive being bigger than 1. And if x is smaller than negative 1, dy dx is going to be equal to 1 over negative x, because we want it positive and we know x is negative, times the square root of x squared minus 1. And we can finally write the formula. Dy dx is going to be equal to 1 over absolute value of x times the square root of x squared minus 1. Why the absolute value? Well, the situation is You keep x if positive, and you write negative x if negative. So you see, that's precisely the absolute value. And this is the table of all derivatives to inverse trig functions. And in this last example, we're going to use these derivatives to derive the function f of x equals x secant inverse of x cubed, assuming that x is bigger than 1. To derive this function, we need to use the product rule, because you see, we have a product in here. So the derivative of f is keep x, derive secant inverse of x cubed, plus derive x and keep secant inverse of x cubed. This equals x times. We apply the chain rule here. So the derivative of the secant inverse is here. We just have to keep x cubed in it. So this is 1 over absolute value of x cubed times the square root of x cubed squared minus 1. And then we have to multiply by the derivative of the inner function, plus the derivative of x is 1, so this is just secant inverse of x cubed. The absolute value of x cubed is just x cubed because we're assuming that x is bigger than 1, so it's positive. Then this equals x times 1 over x cubed square root of x to the 6th power minus 1. The derivative of x cubed is 3x squared plus secant inverse of x cubed. And finally, the x cubed cancels with this x and this x squared, and we're left with 3 over square root of x to the 6th power minus 1 plus secant inverse of x cubed. And we're finished. And this is the table of inverse trigonometric functions, where you can see their domain and range and refresh your memory. Thank you.